Morning, everybody. Thank you. I got like 99% of the names out there. So I'm feeling good about myself, right? 99% that I tried. Sorry, I didn't get to the back. This is the roll sheet, okay? Really, I don't have to do anything with this, and I'm just going to send it around. I've already checked to make sure everybody's enrolled, okay? I am looking for 3 people, so if you're one of the 3 people who wasn't here yesterday, let me know. But what I need you to do is, for the sake of things, would you go back out and fill out last week and this week? All right, I'll just send it around, and you, just check marks. You don't have to initial or anything, right? Just check, right? And don't fill it out for the next 2 weeks, unless you're a time lord and you know exactly what's going to happen, right? But just this week and last week. I did yesterday's, right? So we'll just send this around. We'll start it right here. It'll kind of go that way, and you guys will probably get ignored, right? And it'll go around, and then we'll send it back once it gets to the end, and we'll make it happen. But don't panic if you don't see it. It's not that big a deal. And I stopped sending it around like after the 3rd week anyway, so it doesn't make any difference. And today too. Please tell me that announcement went up. Yes. For the exam topics. Okay, so read that. Did anybody this morning, if you logged in after 7:30, did you see an announcement about the Society for Women Engineers? Anybody see that? Okay. Then I made a mistake. Okay. I'll fix that. All right. It should have showed up for everybody in the division, but it didn't. So I did something wrong. What were we doing? Last time we did like the end of chapter 2 and the vector part of chapter 1, didn't we? Okay. And I tried to give some lame jokes about vectors to keep you interested in math. We're going to use those vectors today, right? We're going to use the skill that we got in figuring out the components of vectors to be able to pull off the main idea really of this first unit, okay? Which is, how do we figure out what that motion is doing, right? If we throw something through the air, how can we predict where it's going to be at what time and how far and how fast? This is the essence of kinematics in 2 dimensions now. Because in chapter 1, we did objects. By the way, it doesn't matter what the object is. It could be a ball, it could be a car, it could be an arrow, whatever it is. It doesn't matter yet. We did 1-dimensional horizontal motion, right? Where something was speeding up or slowing down, like a car. Okay? And then in chapter 1, we also did the 1-dimensional vertical motion, and I tried really hard to convince you that it was just horizontal motion, just straight up and down. It's the same process, it's the same toolbox, all that kind of stuff, right? It's just we swap x's for y's and we go for it. So we're going to combine those 2 things together today. We're going to put this horizontal motion together with this vertical free fall motion, and that's going to give us that. So, what is projectile motion? Well, guess what? It's free fall. It's just free fall with sideways motion. So projectile motion, okay, is going to get it's defined by 2 accelerations. Okay? First of all, the acceleration in the y direction will be negative g. Right? Why negative? Because gravity tries to accelerate things downwards, even if they're moving up. And the other acceleration we're going to worry ourselves with is the acceleration in the x direction, which is going to be 0. Projectile motion, throwing a ball through the air, okay, but in the absence of air friction, which is confusing, right, is free fall. It's just that instead of the free fall where we just drop something or we throw something straight up and down, the free fall here is coupled with constant sideways motion. And why is it constant motion in the horizontal?
Because you only applied 1 force.
The only force, right, as this ball flies through the air, after it leaves my hand and before I catch it, The only force acting on it is what? Gravity, right? It's the only thing, because we're going to ignore air resistance and all that kind of stuff. So, by way of demonstration, and I forgot to warm up this morning, so this is going to be interesting, okay? 3 balls, right? Whoops, see, didn't warm up. 3 balls, right? Huh. My shoulder doesn't like this. Okay, so all 3 of these balls, when they are not in my hand, are doing what kind of motion? They're in free fall, even when they're going up? Even when they're going down? Yes. And so, yes, I can juggle and lecture at the same time, right? Okay, so all of those were in projectile motion as long as they weren't in my hand. Why am I keep saying that? Why is it important that they're not in my hand? Because there would be another push or pull, another force when it's connected to my hand, right? And so all of our analysis that we're going to do is going to involve something being launched or pushed or something, right? But it's always after the push is done, okay? And it's in free fall. And when we say, like, how fast is it going when it hits the ground, it's not after it hits the ground. Because after it hits the ground, what's the answer? 0, right? But like, we have to go up to the point right before it hits the ground, because free fall falls apart at that point. The toolbox that we've been developing, or that we've had, is for the same acceleration only. So the acceleration can't change. And acceleration changes if you're tossing it or it's landing on something. We'll get there eventually. We'll be able to handle that sort of stuff, but I can do it. Okay, so if projectile motion, it makes these assumptions, and it does, then what does the toolbox look like? Yeah, well, okay, almost. I think it looks the same, but you guys are going to probably argue that point. But what does this have to do with vectors or any of that kind of stuff?
Has to include both x and y.
Yeah. So don't write this down. Just don't write the next part down. There's going to be an end part that I'll put in a box. It'll be the important part. But you need to know something about all of the toolbox equations that I've been showing you. They're really vector equations. What's a vector equation? It's an equation with vectors in it, right? Okay. We've been careful, sort of, up to this point to really just say, like, velocity in the x direction, velocity in the y direction. And we're going to continue doing that. But in reality, this equation, and I could write the other 2, I'm just not going to. Is that okay? Because we'll get them all down in a second, okay? In reality, this equation is 3 different equations. Where did those 3 equations come from?
3 dimensions.
3 dimensions, right? Okay. And so our process, the way that we're going to be able to handle this, and don't panic, we're not going to do 3D yet, okay? We are going to use what we know about vectors and being able to find the parts of vectors, the components of vectors. So like if something launches at an angle, we'll find its initial velocity in the x direction. We'll find its initial velocity in the y direction, and then we'll be able to work our way through. Because the acceleration in the x direction is 0, but the acceleration in the y direction is negative g. That's different, and so we need to apply the toolbox separately to those 2 different directions. I know what I'm saying may not make a whole lot of sense right now, but hang in there. It'll be okay. So if I actually did write down the toolbox, our old toolbox, right? Did you see how I picked up extra subscripts now? What do the x's mean? X direction, right? So we see Vx. What are we thinking about? Which velocity? What final? Somebody reads lips, right? The final velocity in the x direction, right? Because that's different from v naught x. What's v naught x? Initial velocity in the x direction, right? So when we had v equals v naught plus at, right? And we were doing that for vertical and horizontal. What we're going to do now is we're just going to be careful. We're going to put x's when we are working with the horizontal part of the motion. And then we're going to put y's when we're working with the vertical portion of the, and we're not going to do z. Don't worry about z. Okay? It's two-dimensional motion, not three-dimensional motion. So I could do that with all of these. Don't write it down yet. What would I write down the second one as? X equals v naught xt plus 1/2 axt squared. And what would the y version look like? Y instead of x, right? But v naught yt plus 1/2 ayt squared. That's an ay. And then the third one, vx squared, v naught x squared plus 2ax times x, excuse me, vy squared equals v naught y squared plus 2ay times y. There we go. All right, so why have I not wanted you to write anything down? If ax is equal to 0, what happens over here? Not everything, but lots of stuff, right? That term is 0, isn't it? Right? If ax is equal to 0, then that one's 0, that one's 0, and that one's 0. And we're left with that statement right there. What is that statement telling you? What does it say? Whatever velocity you end with is the velocity you started with. Duh. The acceleration is 0, right? Like acceleration means velocity changes, but if the acceleration is 0, the velocity stays the same, doesn't it? You can tell that this is a mathematical result because it's true, but useless. That was kind of a joke. Okay. What about the third equation? Same idea, right? Just more horrible because there's square roots in it, right? But what happens with this equation right here? How far you go depends on how fast you're going and how long you do it, right? Distance equals velocity times time, which is sort of a kind of a classic high school physics result, right? So that is useful, right? We can find the horizontal distance something goes if we know how fast it's going horizontally and how long it's been doing it. So if there is a toolbox to write down, now you may write down the toolbox, right? Okay. I would say that it looks like this. This is Mr. Balogh's toolbox for Chapter 3 for this case of two-dimensional projectile motion. Where did my, there it is. Okay. I'm going to write on board because we're going to refer to it a lot. Okay. But you also have it on the screen. No, not squared yet. Vy, v naught y plus ay times t. And y equals v naught yt plus 1/2 ayt squared. Am I getting these right? Sometimes my dyslexic brain doesn't get it right. X equals v naught x times t. So I always think that like there's like a fourth hanger-on equation, right? The x equation just tries to kind of sneak in there for this toolbox. All right, so that's what it looks like when I write it down. Your book, I kind of went and checked, is very similar to this actually, which I was very happy to see. In other sources, online, ChatGPT, all those, anything that's sort of pulling from the internet, you're going to see kind of a different version of these, but they are actually the same thing. And I kind of hinted at this last time. Other books would make the first one, Vy equals V naught y minus gt. Right? They kind of hard code in that negative g. I hate that because we want these to be useful no matter what we're doing, right? Even if we had positive acceleration in the y direction, which we're not going to do this chapter, but eventually might happen, okay? The other thing that you will see happen is they'll start introducing sine and cosine into these equations. Why are we going to need sine and cosine?
Define the x and y vectors.
So what happens if we launch something at an angle theta at a speed v naught? To be able to use it in this toolbox, I'll give you a number. Let's just say v naught was equal to 25 meters per second, right? And theta was equal to 60 degrees, okay? Can I just put 25 in for this v naught? Why not? It wasn't the y direction, right? It was 25 meters per second at 60 degrees. So how do I go and find the y component, which I need the y component over here? See all these y's, right? What do I have to do? How did you know it was sine? V naught y over here was equal to v naught sine theta because it wasn't touching, right? Okay. So you'll see them write things like, they'll say they'll say y equals v naught sine theta times t minus 1/2 gt squared. Now, again, for somebody that's new to this, you instantly think that this is a new equation and new physics is happening, right? But that's not true. This is not a new equation. What equation is this? It's the second one, isn't it? Right? So in my teaching style and over the years as I've coached people through this, I find that this approach is just easier. There's less friction because you already know this toolbox. And the new skill we have to pick up is just to make sure that we figure out what our initial components are, and then we can do everything else. So we're still going to visualize, we're still going to strategize, we're still going to do it, we're still going to check it. None of that changes. Just a little couple extra details we got to sneak in with our newfound vector knowledge. I need an object. What's something you would like to see launched off of a cliff?
Me.
You? Well, we won't go that personal. A rock? It's kind of boring. Football? Yeah. A what? A motorcycle? Now we're getting more creative. What do you got against motorcycles?
No, I just like how they launch themselves.
Oh, you just like how they fly through the air? Oh, okay.
An ice officer.
A what? An ice officer? Yeah, we don't want them coming. No? Nothing more interesting?
All my hopes and dreams.
There we go. Going to launch all of our hopes and dreams off of a cliff, right? We're going to put them all in a box. We're going to launch that. We're going to put them all on a motorcycle. And we're going to... Does it matter what this object is? It makes absolutely no difference, okay? That's why I just put object in brackets and gave your brain something to think about, right, for a few minutes that wasn't the toolbox. Remind me in 20 minutes about, when we're done with this problem, remind me if I forget to tell you, or at least show you, how I am manipulating you. I know that word has a negative connotation, but I'll explain. Okay, because you are being manipulated right now. What do we do? What do we always do when we see a word problem? We panic, right? Okay, we panic, and then we take a deep breath, and we realize that there is a systematic way to approach this. Visualization. Should we draw a picture? Or not? Okay. We need a cliff. There's a cliff, right? And doesn't say what's at the bottom of the cliff. Spikes. Wow. Getting dark. Let's just say it's a lake or the ocean or something. Okay. And then we know that this thing, what do we know about the cliff?
It's 75 meters.
So we know it's 75 meters, like vertically, like this way, right? Okay. And we know that this object, all of our hopes and dreams in a motorcycle, get like launched, right? There's like the initial velocity vector. This vector is 40 at an angle of 50 degrees. Am I reading this problem right? I tend to get my numbers mixed up. Okay. Now, it's not gonna like, the path of this thing is not to do this, right? Okay. It's gonna do something like that, isn't it? The projectile motion is parabolic motion. Well, let's not get into why it's a parabola. It's all mathy, but it's the second equation's fault. Okay. So it might be helpful to just sort of remind yourself, right, that this object is going to kind of do a parabola, right? So that's kind of like what a picture would look like. There's only 3 numbers in this problem, and I'm starting to panic because it doesn't feel like it's enough. Because they're asking me to find what? Everything, right? Right? like there's a lot. Remember the building problem yesterday? Right? I gotta find we gotta find everything. And we're gonna find everything from just 3 numbers. It's gonna be pretty amazing, actually. Okay? So we've got a picture, and now we're stuck. What's another thing we could do to visualize? Oh, okay, so make that list, right? The list of what we could know and not know. Sometimes a list of what we can't know is more powerful than the list of things we do know. It's just, gets a little overwhelming sometimes, all the stuff we don't know, right? At least for those of us who are paying attention. Because there's those people that assume they know everything, and they're just annoying. Turn to the box. The box can teach us, right? What we could know and not know. So what am I going to put in my list? It's the first thing we encounter, right? Vy. What next? I'm going to run out of room. Why am I down here? Vy, V not Y. What comes next?
Acceleration.
Ay. After that? Why is there no ty and tx? Time is not a vector. What comes after that? Y. Okay, do we pick up anything new? We already have a Vy and a T and an AY and a T. Nothing new, right? Vy, do we already have it in the list? V not Y? AY? Y? These are all on the list still, right? Okay. We have something new now with X. Put it in the list. What's the last new thing? V not X. You don't have to do it in this order. It's just the order I do it in because that just falls right out of the toolbox, right? Okay. There's a vector just screaming at me right now. What's the vector?
75.
It's not 75.
40 meters.
It's the 40 meters per second at 50 degrees. That's a vector. Okay? And I need to get it into components. Why do I have to get it into components?
X and Y vector.
Because gravity only works in the vertical. It doesn't work in the horizontal. Remember, AX is 0, but AY is negative G. Okay? So, we better write that AY is negative 9.8. Because it's projectile motion, right? Okay, so we know that. But can I put the 40 anywhere in here? Can I just put 40 right here? No, that doesn't work. That's wrong. Strong and wrong, but only do it once. Can I put the 40 down here? No. It's a vector, right? So let's break it up. I know that the hypotenuse is 40. I know that the angle is 50. And so if I want to find the x component, if I want v naught x, what's it going to be?
Cosine.
Why is it cosine?
Because it's not touching the angle.
No, because it is touching the angle. 40 cosine 50. And then the y component over here, v naught y. It's not touching, so it's sine. If you want to keep doing SOHCAHTOA, you can. That's fine. I'm not going to stop you. You're just going to be behind. It's going to take you a while. So, v naught y, what is it? It's 40 cosine 50, which we need a number for it. I got 25.7. Does that look right? Bunch of good-looking, smart people got the same, so I'm going to go with it. V naught x, we'll just skip down the bottom. V naught, oh jeez. Mr. Balogh, you're fired. Strong and wrong, right? I messed up. And I put it on the wrong line. There we go. Are we okay now? All right. V naught y, 40 sine 50 degrees. And I got 30.6. I'm not done with those numbers yet because I failed to do something. Anybody notice my mistake? I kind of just left them positive without thinking about it, right? But remember, interrogate every number that goes into your toolbox. Should v naught y be positive? Why? It's launching up, right? It's launching above the horizontal 50 degrees, which means it's got pieces that are pointing positively upwards. And then for x, we'll just call that direction positive too. So what I'm going to do now is I'm going to go back here and I'm going to say positive, positive to indicate to future me when I'm all confused about what I was doing, that I tried, and these are the directions I specified, and at least I thought about it. I might have thought wrong. We haven't. We're all correct still. Okay. Have we got all the numbers that we can get in our list yet? What number haven't we dealt with? 75. Where does it go? Goes into y? Then we're done, we can walk away? No. What is it? Why is it negative? Because it goes down. Doesn't matter where it starts. I don't want to waste your time with proving that no matter where I put 0, that's going to be negative. But it's going to be negative because it goes down. It ends up lower than where it started. That negative sign could kill you. Yeah. You'll email me at 12:30, 1 o'clock in the morning, screaming in frustration at your computer. I can see the tears on the email. You say, Mr. Balogh, why did you plus hate me? And I'll look at your work. I'll go, well, you didn't put a negative sign on 75. And when you get that message, your world will end. Because you'll think, oh, I'm so stupid. I shouldn't have heard it. No. Always send me. Never be afraid to be wrong. Never be afraid to be wrong. Matter of fact, be afraid to be right. If you're right the first time, there's probably a mistake. At least that's what I've discovered in my life. You didn't want any parenting advice. Never mind. I didn't say that. Okay. Did we get all the numbers that we could start with anyway? Was there anything that was implied? It doesn't say anything comes to a stop, right? No? All right. So we go through here. Do we know how fast our hopes and dreams on a motorcycle are going when it strikes the water in the vertical direction? No. Do we know how long this thing has been in the air? No. Do we know how far horizontally it is from its launch point? No. By the way, how far horizontally from the launch point would be measured along here? Okay. It is not from here to here. Like the straight line, I didn't draw that very straight. The straight line from here to here, that's meaningless. I don't know what that is. Okay. But horizontal range is the horizontal range, right? It can be measured there, or it can be measured from up here. Doesn't matter, right? It's the horizontal distance, right? Okay. Okay. What are we looking for? Everything, right? So we'll do part A in purple. What do they want in part A? Max height. Okay, so max height is like right there somewhere, isn't it? Okay. What do we know about maximum heights?
It's the maximum height.
Well, yeah, duh. But like, what else do we know? Good. It's when the y velocity becomes 0. Is there still horizontal velocity up there?
Yeah. Yes. No, wait.
Now I've got you second guessing yourselves all the time. Good. Okay. When I throw this, right, and it gets to the top, does it stop? No. What stops? The vertical component of its velocity. But remember, projectile motion means it's always moving in the x. So it hasn't stopped. What's happened is its vertical component has gone to 0 right there, but it's still moving sideways at that point. So what we know is that at max height, remember, leave yourself notes. V, well, in this case, we call it final, right, will be equal to 0. The y component of the velocity will be 0. And that's the only time you can put 0 in for a velocity of any kind, right? When you say a velocity is 0, initial or final, you're telling the toolbox that this thing is at maximum height to begin with or is gone to maximum height, right? It's like hard-coded in there. So if that's the case, and I set Vy to 0, right, what toolbox tool could we use to figure out what this height is? Okay, so the first one, okay, so we know Vy, we know V naught y, we know Ay, so we can get T, but would that T be for how long the object is in the air? That's just the time it takes to get to max height. Did they ask me for that? No, I don't care about that. It's a good guess. The second one? Problem, it's got time in it, right? So could we use the first one and solve for the time and then put that time into the second one and get the answer? Does anybody want to do that math? No. Good. Because we have the third one, right? We don't know anything about time for max height. It's not asking us for time to max height. So if we could ignore time, that would be fantastic, wouldn't it? And the third one doesn't have any time in it. So we know this. We know Vy. We know V naught y. We know what a 2 is. We know our acceleration. And then we can just solve it for y. So what's the plan? Use third. Solve. I can't spell. Solve for y. Right? So that's Vy squared equals V naught y squared 2ay times y. So that's Vy squared minus V naught y squared. I'm going to do this really fast. 2ay equals y. And now I can chuck my stuff in. 0 minus V naught y, we said was a positive 30.6 squared all over 2 times a negative 9.8. Since everything is going in as meters and meters per second and all that kind of stuff, standard units in equals standard units out. I don't have to convert anything. We're good to go. And I got I got 47.8. Yeah? You guys just saying that because, you know. See, I'll agree with the teacher at any time if it gets me an A. I always felt like that in English class. Yes?
When it comes to the third equation that we use, it has v naught y squared plus 2a y and y.
Mm-hmm.
How is that written exactly? I know I see it's a bigger y, but
AY times Y, you could put a dot in there if you wanted to.
and then I'm still putting both y and y, but just
Well, the acceleration in the Y direction, which is negative 9.8, right? And then the distance, which is what we're solving for. I was taught to put a delta in front of this Y just to make it look more distinct. Your book doesn't do that, so I'm trying to be consistent with your book. Because really that Y is a delta Y. But you guys don't need to worry about that too much. Okay, so if I put 47.8, if I box it and I throw it into Wiley plus, it's going to turn red. Why?
Because you need to find
This Y is the distance, this drawing is not the scale, above the launch point. We just told it, start at 30.6 and go up to your 0. And the toolbox said, yeah, that's 47.8. But the problem doesn't ask above the launch point. It asks above the ground at the base of the cliff. Oh, it did say ground. It's not water. Oh, well. The ground at the base of the cliff, right? So we have to add, to get the answer for Wiley plus to be happy, we've got to add the 75 meters. This doesn't always happen, but for this problem it does. So I got 122.8 meters. That's the one that would go in the box. So do you see how easy it is to do it all correctly and still get a red box? Remember, when you see the red box, what do you assume? I'm right, you're wrong, and now I'm going to prove it to you. And you might find out that you forgot to add in the 75, in which case you roll your eyes and say, okay, fine, computer, you win. And then you'll fix it and you go. But like it gets you into that mental state of being able to do it. Okay, part B, total time of flight. We want the whole enchilada. We want the time from here to here. So we're looking for this. We'll do that one in green. We're looking for that. What do we do? The first one. Do we know Vy? Yes. No. We know, do we know how fast it's going down here? In the vertical direction? No. We don't. So that's two unknowns in the first equation. What about the second equation? It's possible. I don't want to because it's quadratic. But it is possible, right? T is the only thing I don't know. What about the third equation? Doesn't have T in it, which is what I'm looking for. But back to Drew's point, could we use the first one and the third one together to avoid the quadratic? Now, if we look ahead, part D is asking us to do what? Find the components anyway. So should we just do everything at the same time? So should we use the first and the third because we're going to need that for the part D answer, and then use that to find the time? Do it that way. Or do you want to see a quadratic? You do? You don't? Half of you want to see me suffer, and the other half like me. Thank you. No, it doesn't matter. Quadratics aren't that bad. But we'll do, oh heck, we'll do quadratic. We're going to use the, V naught y. You always got to remember to copy your tools down correctly. 1/2 AYT squared and solve for t, right? So to do that, I got to go into quadratic land. And when I have to do a quadratic, I just put numbers in. I don't do it symbolically. Symbolically is just horrible. So what is y? Negative 75. What's v naught y? Positive 30.6 times a t. And then this magically becomes negative 4.9 t squared. How did I know that was negative 4.9 t squared? It's half of negative 9.8, and that happens all the time, and I have simply didn't try to memorize it, but it just got burned into my mind, right? To the point now, sometimes I write down 1/2 times negative 4.9, and then I just get really screwed up. But that's what it is. Quadratics. My teachers taught me I had to put everything on one side equals 0, which they were correct, but they told me I had to make the thing that was squared positive, which was incorrect. My math teacher lied to me. So I'm not going to do it. I'm going to put 0 over here. It's going to be negative 4.9 t squared plus 30.6 t plus 75. What did I just do? Did I move the 4.9 around? Kind of. I didn't move it across the equal sign, right? I reordered the terms. So I would have t squared, t, and then nothing, right? But then I needed to get the negative 75 over so that I could see what my a was. My a is negative 4.9. My b is equal to 30.6, and my c is equal to 75. And then I go chuck it in the quadratic. And how many answers do I get? I get 2. Negative 1.88 and 8.12 seconds. So which one do I pick? Why? Who taught you that? I'm guessing somewhere some math teacher told you that. Time can be negative because all the positives and negatives in these equations are artifacts of our choices. Okay? What's more, you can set up quadratics. Like I could have moved this the other way and done some other things and come up with positive 1.88 and negative 8.12, which would have represented a changing of what we call positive negative anyway. I'm going to say it's okay for you to look at it and go, oh, well, the one negative's not possible. It actually is. Realize that in doing a quadratic, you asked a question. Does anybody know what the question was? What time values occur at negative 75? Remember, this equation is quadratic, isn't it? It knows, unfortunately, the entire parabola. And so when we said negative 75, we said, okay, what time is the ball here? And there are 2 answers. Can you see the negative one? Where's the negative one? It's over here, isn't it? Okay. The shorter part. The longer part, which is the actual physical part of our motion, right? So what we have here is like a mathematical artifact, right? But positive and negative can be changed willy-nilly depending on how you put it in the quadratic and all that kind of stuff. If you're careful, the positive answer is the correct one. What's more correct is to realize that there is more of this parabola to do, right? In the parabolic shape that is the motion, this ball has to go up before it comes back down again, right? What happens if you launch downhill? What if your parabola is like this, but you launch here and you're only doing this section? You want the shorter time, even if it, right? Because again, mathematical artifacts. But that's probably getting too much into the weeds, and we'll just go with time can't be negative. And we'll say it's 8.12 seconds. So there we go. What else do they want to know? Horizontal distance from the launch site. Oh, how are we going to find the horizontal distance from the launch site? 30, no, not the third, because we can count, right? So this is the only one that's got the horizontal distance in it, right? So plan, use the fourth equation, solve it for x. Hey, it's already solved for x. This is going to be 25.7 plus on it. And then what time am I going to put in? 8.12, because that's how long it was in the air. And I got 208.7 meters. And then finally D, I've run out of colors. The components of the velocity at impact. I already know one of them. Which one do I know?
The x component.
Yeah. What's the x component of the velocity at impact?
25.7.
It's 25.7. Why is it 25.7?
Because the
It never changes, right? It never changes. What it starts with is what it ends with. Okay? And I'll find the... Can I use the first equation to find this? Yeah, I know the time now, don't I? Can I use the third equation? I could, but then I'd have to square root and pick a positive or negative or something. Which one would you pick? Positive or negative? If we use the third one.
negative.
Negative, because it's going down. But v naught y plus ayt, that's equal to positive 30.6 minus 9.8 times 8.12. And when I did that, I got negative 49. And I didn't put a box on that one. That was an amazing amount of math, wasn't it? When we started with knowing only 3 things. This is what we try to do in physics. We try to figure everything else out, starting with very little information. Luckily, we've got toolboxes in the universe to teach us how it works. What was I supposed to do? What were you supposed to remind me of? How I'm manipulating you. Has anybody figured it out yet? Forcing you to engage. How am I forcing you to engage? What? Okay. No.
By talking to us.
I do that all the time. That's how human beings communicate.
Like asking us questions.
Okay, but that's just like Socratic method. And if I did that for an hour and 15 minutes, you guys, your brains would burn out right away.
You make purposeful mistakes.
You're getting closer.
You're making us engage with the problem.
No. Every 5 to 10 minutes, I hit a psychological reset button. Have you noticed? No? Every 5 to 10 minutes, I take your brain in a direction you were not expecting with a little tangent, a little joke, a scream, a diverting of your attention away from what? The physics that's going on. And then have you noticed what I do when I bring you back?
You continue like nothing happened.
No. I go, wow, what are we doing? Boom. Let's get back to this. What have I just done with your attention span? I brought it back. So what is the average adult's attention span? No. Actually, it's 10 to 12 minutes. It actually depends on the kind of lighting you are under. Under fluorescent lighting, it's less. So 10 to 12 minutes. And it is shortening. I blame TikTok and YouTube Shorts. It's anywhere from 10 to 12 or 10 to 15 minutes, depending on which body of research you want to refer from. That means after about 10 minutes, so for some of you shorter, for some of you longer, but on average, every 10 to 12 minutes, what does your brain want to do? It wants to take a break. It wants to switch to something else. And you feel it, right? You'll start to blank out. You'll start to daydream. You'll start to think about something else. You'll realize you haven't heard the last 30 seconds of what's going on in class because your brain was screaming for release. Its attention needed to be diverted somewhere. Okay? So if I can get in there, I can have you focusing on physics for a little bit, right? And at about 5, 8, 10 minutes, I can all of a sudden point your brain somewhere else. What's going on outside? What's this thing on the board? What's this stupid joke? Hey, I'm a dad. I give dad jokes. Hey, I'm fat, whatever. Like, it doesn't matter what it is, right? If I direct your attention to something else, 5 seconds, 10 seconds, 2 minutes, depends on the tangent, right? At the end of that tangent, and I say, what were we doing? Oh, let's get back to physics. What does your brain do? Jumps right back in, right? And is ready to go for another 10 minutes or so. Over the hour and 15 minutes, the intervals get shorter because your brain does get tired, right? But I want you to know, right? I'm a professional teacher. And part of that is knowing how brains learn physics, right? And so I will do anything, including making a fool out of myself. Not to entertain you, but to do what? Engage you, keep you here, keep you focused, right? Keep you going. Which is why students have told me, excuse me, coming out of my class, Mr. Balogh, that went so fast. Like, I can't believe how fast that went. It felt like I was only there for 20 minutes, but we were there for an hour and 15. I've heard that. I've also heard Mr. Balogh was the longest day of my life. Please don't do that again. That's physics 2B. But also, students will report to me that they walk out of my class feeling tired. Like their brains have really been worked, right? So it went fast, but oh my gosh, I have a headache, or oh my gosh, my brain's full, or I've got to go decompress and play a video game, or whatever, right? So, yeah, I understand that about humans, and I use it to my advantage in teaching situations. In regular conversation, I'm a wallflower. I won't just if I go to a party, I'll stand at the wall. I don't want to talk to anybody, but for you guys, the world. All right. What does this mean? Quit. For those of you that are now panicked that that's what the test is going to be like, I will not do that to you on an exam, right? There's not going to be any third hidden answer, right, or something like that, right? Okay. On the conceptual question, one or more of the choices is correct. It'll tell you, right? Circle all that apply or whatever, right? But like, there isn't a hidden one that's not there that Mr. Balogh thinks, you're trying to find or whatever. Okay, what I would like you to do for this one is I would like you to turn to your neighbors, like right now, and start visualizing together. So you can draw on your notes or make the list together, right? Like, I want you to just talk with each other and describe what you're writing down and why you're writing it down, and maybe come up with a common list or something like that. But I just want to hear noise for like the next 4 minutes as you visualize together. Go. What's the first letter of your first name? It's what? G. Is this why I'm having trouble? Gabby, right? Gabrielle? Right.
She's
But
Gabriella and Gabrielle. So we both go by Gabby.
Did you tell me Gabrielle yesterday?
I said Gabby, I said you can do both though.
And what did you tell me? You're both sitting together, which is why I couldn't figure it out.
Weird coincidence.
You did that on purpose. Yeah, okay. Gabby and Gabby, right? Your name is me, right? And Jose? And Lewis?
Yeah.
Don't say it wrong. Caleb. Gianni. Jarrett. Oh wait, your name is Addison.
We just solved.
And you're Aiden. And you guys did it on purpose, didn't you? Sat right next to each other to confuse me. If you've got the visualization down, strategize. Talk about how you're going to do it.
Equation 1 to find Vy. So we can use the second.
Max. Right? Nishte. Did I say it right? Amrit. Is that right? Yep. And Matab. Did I say it right? And I got you to.
Yeah, the negative 4.9. 0.4. I got negative 0.99 meters, which means the initial height is going to be the wall of that 0.9.
How'd I do? I think I made one mistake. It's a minor one. It's probably not going to get me in trouble, but I should have done better. Does anybody see it? Missing units? On what? No, I've got, well, I didn't put it on 0 because 0 is 0. Yeah, on the V naught X, right? I didn't like interrogate my number, did I? Okay. So I managed to get it the minus sign on my G, right? Negative 9.8, but I didn't put that. It wouldn't, in this case, it wouldn't have harmed me, but like, shame on me for not showing you the right way to do it. But good catch. All right. Owen. Is that right? Yeah. Nailing it today. All right. So, with your names. So, what's the plan? Well, okay, yeah, but which one? What do they want to know? How high above the ground? What are they asking for when it's how high above the ground? The Y, right? They're asking for this right here. Okay? So to do the first question, it's not labeled as A, but it's the first question. What do we do? Second equation? What is the second equation? Is this going to work? Do I know V naught Y? Yeah, what is it? Oh, one of my favorite numbers. Minus 4.9, and then do I know the time? Yes. 0.45 seconds, right? Squared. I don't even have to do algebra, right? It'd be really convenient if I actually had this one in my notes. I do. I got negative 0.99 meters. So I box it, I put it in Wiley Plus, and it goes, Why would it go? Meh? Okay, so yeah, this comes up a lot. Mr. Balogh, the answer's negative, but it would only take the positive version. What was the question?
What was the initial height?
Yeah, how high above the ground, right? They're really just asking for a distance there. Other places you'll see this crop up as if they ask for the magnitude of the velocity. And you're like, but the velocity's down, so it's got to have a negative sign. The word magnitude, when it comes to vectors, means what? Just the number, right? Just the size of the vector, not what direction it's going. Direction is positive or negative. So if they ask for the magnitude, they just want the number. And magnitudes default to positive things. Here they ask for the height. It's just a distance, right? Why was this question negative? Why was this answer truly negative?
Because that was the displacement.
It's the displacement of the ball, right? The ball went down. And that's what the equations told us. It went down 0.99 meters. The question was simply asking how high above the ground was it? So our box should technically just be 0.99 meters. Subtleties, yes. Splitting hairs, yes. If I asked you on an exam, how high off the ground was it, and you said negative 0.99, and that's correct, and you showed all of your work, what do you think I might do? Death. Straight for the, no. I'd probably go, you know what, they did this right, -0. I put -0 to indicate that there is a mistake, but I don't think it's, like you showed me you know how to do physics, right? And so I'm content that you know what you're doing. And on an exam, it's easy to forget. Height above isn't negative, whatever. I tend to be forgiving on things like that. Miss the minus sign on -75 in the last problem, I'm coming after you. Because that's a big physics mistake. Okay? And you're like, that doesn't make any sense. Well, it kind of does. All right. How do we find how fast the ball's going when it strikes ground?
Find the final y velocity.
Okay, so can we use the first equation for that? Yeah, look at that. 0 minus 9.8 times 0.45. I got negative 4.4. So again, why is this velocity negative? It's going down, isn't it? When it hits. So I bought 4.41. It just says speed, so it's 4.41 meters per second. Put it in a box. I'm done? No. Because this is not the speed of the ball. What is 4.41? The vertical component of the velocity when it strikes the ground. When this ball flies off and strikes the ground, the equations, the toolbox can give us the final y and sort of the final x. So what we got was negative 4.41 for over here. What they're asking for is the magnitude of this vector, the speed. Speed is the magnitude of the vector. This vector has two parts. It has a y component of 4.41 and an x component of what? 7.7. So how are we going to find the magnitude of the speed? Magnitude of velocity, the speed of the ball when it strikes the ground? 7.7 squared plus 4.41 squared. Why did I drop the minus sign? Squaring everything anyway. That's the speed that this thing hits the ground. Remember, when you solve for Vy, that is the vertical piece of the motion at the end, terminating point that you've defined for the motion, right? It's a piece of the speed that the object has because it's also going sideways. So when they ask for magnitude, they ask for speed, they ask for something like that, then they are going to be asking you to do some Pythagorean theorem. All right. Next week. What's happening next week? The exam, right? Okay. I pretty much got through all of chapter 3 that you need to be successful. Okay? To do your homework, all that kind of stuff. When's the chapter 3 homework due? Wednesday. What's the only grasp between now and Wednesday that you can get your questions answered for chapter 3? It's tomorrow. What's due on Saturday? Chapter 2 homework. There's a lot to do, isn't there? Next Tuesday in this class, we are going to review for the exam. In my class, review means that you come with questions for me. Mr. Balogh, like, people ask me, Mr. Balogh, why don't you have a sample exam? Well, actually, I do. I've got 2 questions so you can see sort of the format of the exam. But I don't have like a practice exam for you. Because my answer for, well, could I have some practice, Mr. Balogh, is, yeah, I gave you homework. Right? So if you want more practice, do more homework, right? Come to me with questions on Tuesday. Maybe they're about chapter 3 homework problems. Maybe they're about the other stuff, right? I posted the topics so you know what to study for, what the questions are going to be on the exam. So take advantage of all that. Wednesday, what's happening? It's lab 4. Okay? We'll be doing lab 4. You need safety goggles for that lab. We have safety goggles that we can sterilize and provide for you. However, if you have your own pair of goggles that you either use for chemistry or you work in a shop and you just have a pair that you really, really like, you can bring those. They just have to be rated for impacts, and I can tell just by looking at them. They do not have to have the gasket. We're not trying to stop spills. We just want impacts, okay? So next week, you need goggles on Wednesday, but we can provide some for you if you don't have any. Tuesday is going to be review for the exam. That means you coming to ask me questions. Homework is due on Wednesday night for chapter 3, and we're taking the exam on Thursday. Just don't go to your other classes. You'll be fine. If I don't see you in GRASP, have a great weekend.